5, Section 3. So far in this chapter, we've looked at how we go from rectangular estimations to an exact area under a curve. Notice, we've been using the function and the x-axis as our upper and lower bounds when estimating the area underneath this curve. So the question that comes up naturally is what happens if the function is underneath the x-axis? Well, what happens is that any area that is below the x-axis we count as negative. If you were to draw on the rectangles to estimate this, you would do width times height to get the area of each one. Well, the width would be the same, but the height would be counted as negative because we're looking in the downward direction. So for example, if you look at the function x squared minus 1, and you want to look at the area from negative 1 to 1 underneath the curve, it's an area that's strictly below the x-axis. So if you were to do this on your calculator, it would spit out the number negative 1.33. And the reason you get negative numbers on your calculator when you do certain integrals is just that there's more area underneath the x-axis than above. So again, whenever you're calculating area underneath, you're going to count that as negative, and anything above we count as positive. So sometimes they word it in such a way that it can become a tricky question. So if you want to compute an integral, and you are asked to just find the integral, you'll do it straightforward on your calculator. So if we look at this function here, which is x cubed minus 7x squared plus 11x, and we want to know the area under the curve from 0 to 4, what your calculator does is it computes the positive area and the area below, and it subtracts off the area below. It knows to count it as negative. So if you were to do this on your calculator, it would spit out 2.67. And what it's doing is it's taking the area above, A1, which is 7.72, and the area below, 5.05, and it subtracts off area 2 because it's below the x-axis. If you are asked to find the total shaded regions, this is a different question. So when we're looking for total area of shaded regions, they want you to count both as positive because it doesn't matter if it's below or above to get the total shaded region. So you would have to calculate each separately and then add them together. So if you were to do this as a straightforward integral, you would not get the right answer. Instead, you would have to break it up into two integrals exactly where it crosses over the x-axis. So you can see that on the bottom right hand side, I've broken it up into two integrals. So we go from 0 to 2.38, because that's where it crosses over the x-axis, and then from 2.38 to 4, which is our other endpoint. And whichever piece is below, you're going to calculate in absolute values so that it gets counted as positive. So this is the same as adding the two areas together, so 7.72 plus 5.05. So the total shaded area would be 12.77. What if we want to look at the area between two curves? So now we've looked at area between a function and the x-axis, where the function's above and where it's below. But what if we just have two functions and we want to know the area between them? Well, just look at the f curve, which is the one on top. We know how to find the area from a to b below the f curve, and we also know how to find the area between a and b of the g curve by using integrals. Well, if you subtract the area underneath the g curve off from the area underneath the f curve, it leaves you with just the area in between. So, when you want to find the area between two curves, you're going to take the top function and subtract off the bottom function and integrate them from a to b. Let's look at an example. So if we wanted to find the area between the curves x and x squared, between x equals 0 and x equals 1, well, we need to figure out which one is on top in the given interval, so between 0 and 1. There's two ways to do this. You can graph this on your calculator, just graph both equations using the graph button, and just look to see which one's on top. Or you can plug in any number between the bounds, so between 0 and 1, into both functions, and whichever one gives you a larger y value is on top. So here, the x will be on top because it will be above the x squared. Once you know which function's on top, you do the top function minus the bottom function, so that gives us the integral from 0 to 1, those are our bounds, of x minus x squared dx. Well, you're going to do this part on your calculator, and you'll get 0.1667. Now, if you are given two functions and you're not given bounds, so here we were given 0 to 1, if you're not given any bounds, you have to find them yourself by figuring out where these two things intersect. The way you do that is just set the two functions equal to each other and solve. Now would be a good time to try some of the homework from Chapter 5, Section